Okay, guys, November 14th, graphing systems of equations. So we've had lessons on graphing one equation or one inequality at a time, and now we're going to go to graphing more than one equation. So we're back to equations, so we don't have to shade anything right now. But for your information, a system means more than one in math, so we're going to go with the easiest more than one, 2. There are 3 possibilities when you have 2 equations on a graph on the coordinate plane. So let's talk about those 3. So you can have 2 lines that actually have different slopes and different intercepts, or same intercepts but different slopes, and they will cross once. So the solution is one solution. And then another situation is where you have 2 lines on a coordinate plane, but they happen to have the same slope, different y-intercepts, so they're called parallel. They will never cross, so there's no solution. And then look at this third case. So one solution, no solution, and then the third case is you have a line, you graph it, and you don't realize that until you start graphing that the other one has the same slope and the same y-intercept. So you have the first line, and then the second line just is the same exact slope and same exact y-intercept. It's the same equation. And so they cross infinitely. They're the same line, infinitely many solutions. So those are the 3 cases. And so when you, what you might write is, here you'd write the ordered pair. And because you just say, okay, this is where they cross at x comma y, or whatever it looks like here, -1 comma -3, something like that. And then the next one you'd say there is no solution, and then the last one you'd say infinitely many. And so those are the 3 possibilities with systems of equations. So let's look at a couple of examples. So example 1, this one wants us to graph each system of equations. So remember, there's going to be one solution, no solution, or infinitely many solutions. And if there is one solution, always give the coordinates. So write down x comma y as the answer. So our first system is going to be, do you guys notice something there? So we've got y equals -x plus 1 and y equals -x plus 4. Some of us might look at this and say, I don't even have to graph this. I know that there's no solution. They're not the same equation, so it's not infinitely many, but they do have the same slope. But let's say we didn't get that. We want to just graph them. And sometimes in ALEKS it makes you graph them. So you just graph it. Start at +1, go down 1/1, and there's our first equation. Notice I went down 1/1. I even did it a couple more times. And so for our second equation, we're going to start at +4, go down 1/1, and you see that these are parallel. And so the answer is there's no solution. So let's look at part B. So this one, we're going to get different slopes, and so there is going to be one solution. So that first equation, the one that we're graphing right here, is actually the second equation that's written down. It's y equals -x plus 1, and that's the same as the first equation from part A. So that was an easy graph. We know what it looks like. And maybe we want to just plot a couple more points just in case, and it makes sense to be real careful here to plot a couple more points. So notice I have 4 points plotted. Hopefully the other line crosses one of those points so that it's easy to say what the answer is. But to graph the other line, or the first equation there, to graph that I got to write it in slope-intercept form. Or I could have used x and y-intercept because it is in standard form. Anyway, so I minus 3x from both sides. I get -3y equals -3x plus 9. Divide everything by -3, and I get y equals x minus 3. So I start at -3. That's my y-intercept. And the slope is up 1/1. So I'm going to graph those, and notice that, if I go up 1/1 twice from -3, I know exactly what the solution is. This line crosses at 2 comma -1. Okay, now, if you graph very carefully and you plot lots of points, you can find the exact solution. But sometimes it just makes more sense to use a graphing calculator. So if you get your graphing calculator, push the y equals button, it'll give you a list of y equals. put the first equation in for y1, put the second equation in for y2, and then push, I believe, second trace, because that will go to calculate. You want to calculate the intercepts. Push number 4, because it will say, do you want to calculate where these two intersect? And then you push 4, or enter down on 4, and then it'll take you to the screen. You push enter 3 times, and it will give you the solution, if there is one. Or you'll look at the graph and see that they're parallel. Or maybe the graph is just off the coordinate plane that they offer, and so you can kind of see where you'd run into problems. So that if you do graph, you need to graph really carefully to find the solution sometimes. With these examples on these notes, and usually in ALEKS, it's pretty easy to see if they're asking you to graph. So if you just want to double check your work, it would make sense, and it wouldn't be a bad idea to use the graphing calculator. Okay, let's look at this last example. Example 2, I'm going to look at 3 different systems. So A, B, and C. And so after we write all these out, let's work with A first. So we got to solve both of these for y. So notice I'm doing that kind of quickly here. First, I minus 2x from both sides to get negative y by itself, but respecting the negative was still there. So I have to divide everything by -1, or times by -1. And I get y equals 2x plus 3. Okay, and so now let's work with the second equation. And when first of all, I minused 8x from both sides. I was left with -4y equals -8x minus 12. Divide everything by -4. And then we see that, oh, they're the same exact equation. So the answer is infinitely many. Okay, look at part B. I'm working with that first equation first. And so I'm going to minus x from both sides. So that gives me -2y equals -x minus 2. And respecting all the negatives, I got to divide now, because y is being times by -2. I got to divide everything by -2. And I get y equals 1/2 x plus 1. Okay, great. Now let's work with this second equation. We might see something before we have to graph these. So I'm going to minus x again from both sides. Oh, we're having to do the same work. We probably are going to end up with the same slope here, maybe even the same equation. Divide everything by -2, and I get y equals 1/2 x minus 2. They have the same slope, but different y-intercepts. These are parallel lines, which means they'll never cross, so there's no solution. Now notice part C. They're both solved for y. They don't have the same slope. I'm going to have to graph them. So first one has a y-intercept at -4, so I start at -4, and it has a slope of 1/1, so I'm going to go up 1/1. And I graph that line. Be real careful. Notice I was really careful there. I plotted a bunch of points because there could be a lot of possible answers. Okay, the second equation I'm going to do in blue here. Start at -2, and I go up 1/3 as my slope. So up 1/3, oh, luckily I was careful with the other one because I see that this goes through the other equation right there. And notice I'm going up 1/3 one more time just to show the rest of the line. And I see that the solution is at 3, -1. And I could even plug that into both equations, and if it works, great. All right, so that's your notes for today. Hopefully everything worked out all right. If you need to look at an example a little bit closer, that's great. If you need to take more notes in ALEKS, work on ALEKS. And good luck, guys. Have a good day.